This problem is to use the sequence of partial sums to determine whether the series converges or diverges. Consider an infinite series where each term is 1 divided by the product of n and n minus 1, and where n starts at 2. A student begins calculating the partial sums of the series and notices a clear pattern emerging. Use this sequence of partial sums to determine whether the series converges or diverges. If the series converges, find its exact value. First step, we begin by looking at the general term, which is 1 divided by the product of n and n minus 1. That expression can be rewritten as the difference between 1 over n minus 1 and 1 over n, using partial fraction decomposition. This allows us to see that the series becomes a sum of terms like 1 over 1 minus 1 over 2, plus 1 over 2 minus 1 over 3, plus 1 over 3 minus 1 over 4, and so on. Next step, this creates a telescoping pattern, a special structure where most terms cancel each other out. When we write out the partial sum of the first k terms, everything in the middle cancels out. Only the very first positive term, which is 1 over 1, and the last negative term, which is 1 over k plus 1, remain. So the partial sum is 1 over 1 minus 1 over k plus 1. Next step, as k becomes very large, the value of 1 over k plus 1 becomes smaller and smaller, getting closer to 0. That means the entire partial sum gets closer and closer to 1. So we conclude that the series converges, and its total sum is exactly 1. The infinite series converges, and the total value it converges to is 1. Here's the tips. Look for opportunities to break fractions into partial parts. If the terms begin to cancel, you found a telescoping series, which is one of the easiest types to evaluate. That's it for this question. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel. If you're looking for tutoring on final exam level questions, check out my YouTube channel at MathTutor8285. You'll find helpful explanations and strategies to ace your exams.